with respect to the spin axis of the star is a little bit different, such as here. So here, the star is still spinning, but now the planet's sort of going in this direction. There's a slightly different shape to that curve. And furthermore, if it's either further inclined, then the shape is even more eccentric like that.
Excuse me?
Yes?
You're speaking of the inclination of the orbit plane with respect to the spin axis of the star, not with respect to the line of sight.
Correct.
Earth.
Right, correct. Now, what's not shown here is if the planet's orbit is in the reverse direction, if it's a retrograde orbit, what's going to happen is that little hump is going to occur on this side of the curve. And because what's happening is the planet is changing first blue shift and then red shift, but if it's in the opposite direction, you're going to get that effect. So that's how astronomers can determine the direction of the orbit relative to the spin axis of the star.
What are the axes on those graphs at the very bottom?
I'm sorry, here?
Yeah.
That's a good question. This is time, and this is radial velocity. So this is going across, looking at the radial velocity in kilometers per second, which is this axis, over time. So the period of that orbit of the star and the planet is this phase. This is the time, the period of one orbit, and this is the kilometers per second here. So it's going to us and away from us with every change in period. Okay?